Hi, welcome back to my channel. My name is Gina. In this video, we are going to look at an example on Newton's second law on an inclined plane. If you haven't watched the first two videos on Newton's laws and type of forces and examples, I'll put the link up there. In this example, a block has mass of 5 kilograms and the block lies on the fixed inclined plane with an angle 20 degrees to the horizontal. The coefficient of kinetic friction is 0.1. In part A, we want to find the acceleration of the block as it slides down the plane. And in part B, we want to find its final speed if the block starts from rest and 10 meters above the surface. When we work problems on an inclined plane, we usually define the x-axis as the axis parallel to the plane, and y-axis will be perpendicular to the x-axis. So here I'm going to define x-axis is positive in this direction, and the y-axis is perpendicular to the x-axis. Now let's start the problem with drawing forces on the diagram. So even though we define the x and the y-axis as tilted, the gravity force is always pointing directly downward. And the block is in contact with the plane, so there's normal force that is perpendicular to the surface. That would be in the y-axis. And the block will be sliding downward, so kinetic friction will be in the opposite direction. Now let's use Newton's second law to find the acceleration. Let's start with the y component. F net in y, by Newton's second law, it equals to mass times acceleration in y. And since the block will be sliding along the x-axis, so acceleration in y is 0. Net force in y, there is the normal force and the y component of gravity force, and this is pointing in the negative direction. And the net force equals to 0. Now let's find the y component of the gravity force in terms of the angle and the magnitude of gravity force. If we project the gravity force onto the x and y axis, we get this is Fg in y, and this is Fg in x. And this is the same angle as the angle of the plane. So Fg in y would be the magnitude times cosine theta. And if we isolate for the normal force equals the y component of gravity force, which is the magnitude times cosine of 20. Now let's look at the net force in the x direction. F net in x, by Newton's second law, it equals to mass times acceleration in x. F net in x, there is the x component of gravity force in the positive direction, and the kinetic friction is in the opposite direction. And this equals to mass times acceleration in x. Gravity force in x is the magnitude times sine of 20, and kinetic friction is the coefficient times the normal force. Here we can substitute the normal force that we found from balancing the forces in the y direction, which equals to mass times g times cosine of 20. And this equals to mass times acceleration in x. We can cancel out the mass. So acceleration in x equals to g times sine of 20 minus coefficient, which is 0.1 times g times cosine of 20, which equals to 2.43 meter per second squared. Then in part B, we want to find the final speed when the block reaches to the ground. And it's given that its initial height is 10 meters above the ground. So to find the final speed, we want to use the kinetic equations, and the distance traveled would be this part. Let's call this D. We can use the geometry to relate the height and the distance traveled and the angle. So sine of 20 equals to opposite divided by hypotenuse. So D, distance traveled, equals to 10 divided by sine of 20, which equals to 29.24. Now let's use the kinetic equations. We know that distance traveled, delta x, is 29.24 meters. We also know that initial velocity is 0. From part A, we found that the acceleration along the x direction is 2.43. And we want to find the final speed. We can use the third kinematic equation. Final speed squared equals to initial speed squared plus 2 times acceleration times delta x. We substitute the numbers. Initial velocity is 0. So final speed squared equals to 2 times the acceleration is 2.43 times delta x, which is 29.24, which equals to 142.11. So the final speed is square root of 142.11, which approximately equals to 11.92 meters per second. And that is the end of the video. If you like my videos, please like and subscribe, and I'll see you in the next video.